This video will be about the engine build for the spare bucket. The engine that's going into it will be made out of multiple leftover parts from MB100 engines that I've built in the past. As you can see on the bench here, I've got quite a collection. The crankshaft has been rebuilt and has a Procross rod kit. And I've also put in a flat silver plated cage in the big end and silver plated thrust washers as well. These Procross rods I've got a bit of experience with and they're very durable. The last MB100 engine I built used a reduced stroke crankshaft, but had a 5mm longer rod and used these KT100 pistons. The cylinder is one I've had for quite some time. It has been vastly modified with extra ports on the intake side. See these ones each side of the main port, but they've been added in. This cylinder has suffered a number of major explosions. You can see there's a nick out of the top of the exhaust port. There's scrapes up the side of the barrel over the transfer, and there's some more on the other side as well. Big one there where the little end pin's been smacking into the bore. There's also chunks being taken out of the base. Now this was actually worse than what this looks, mainly because I've machined about 5mm off the base of this cylinder. The important parts of the cylinder above the exhaust port are actually still in reasonable condition. So I'm hoping to get 20-22 horsepower out of this when I put it together. Not too flash, but for a freebie take for a ride type bike, plenty. Given a change to a standard length rod and with the KT100 piston, there's been quite a bit taken off the bottom of this cylinder, which already had some taken off it. I had to take a further 3.5mm off. So you can tell there's been a fair bit taken off because these septums between the transfer ports are typically recessed down inside this area here, but as you can see, these ones have actually been machined off. So quite a bit taken off there. There was already quite a bit taken off the top, and I've just taken a further skim just to get it dead square with the bore. So what I did when I was doing the machining was I set it up so that the cylinder gave reasonable exhaust and transfer timing. I know it's not the best way of sorting it out. You should be looking at blowdown time areas and all sorts of stuff, but like I said, this is not some all-out race bike. It's just something to get going so people can have a ride. So I got the timing in the ballpark, about 192 degrees exhaust and about 130 transfer timing. The transfer ports have got different roof angles, and there's a whole pile of other work done inside this cylinder. But as you can see, the piston actually sticks out the top of the cylinder, which I've had this before. As long as the rings are still within the bore, it really doesn't cause much problem. And I have this 2mm thick copper gasket, which solves that problem rather nicely. Originally, to fit the head onto the cylinder and to locate the combustion chamber perfectly in line with the bore, there were 2 of the head bolts built up with braze and then machined down. 2 of these holes in the head and in the cylinder were then bored out to take these bolts, and these were used to line the chamber up on the bore. What's happened over a period of time, this head's been used on other engines and this has been cut and it's not lining up now using these bolts. So this shot, you can see just the edge of the combustion chamber inside the cylinder edge. So that's the difference. It needs to be changed so that it all lines up. So the way this combustion chamber is going to be aligned with this bore is through this small piece of aluminium I've machined up. So you can just see there's a very small step on the edge here which fits into this. Now there's a bolt goes through from the spark plug and clamps that into the head, and then the whole lot is picked up and dropped into here. Now this is a very good fit in this bore here. I'll just put it together and show you. Here is the aluminium that I spun up, bolted into the head. So that is perfectly aligned with the combustion chamber. And how it works is, this is put onto the cylinder and everything is aligned by that little piece of aluminium that I spun up. It's a pretty tight fit, so it's quite difficult to get in. With the head fitted to the cylinder and perfectly lined up with our little alignment tool we made, the lot will be dropped onto this little jig which we made up previously. Yet to be done is we're going to put 8mm bolts through here to T-nuts to mount it on the mill. So this will be clamped directly to the base of the mill. It's been machined top and bottom, so everything's nice and square. These studs will actually be removed. The cylinder will we might leave two in. The cylinder will be bolted down on top. We were thinking maybe use two of these studs might be left in the holes which are already oversized and used to clamp the head down. So this will be bolted to the mill. This will be bolted down to this and lined up more or less as best we can to get the current original unmodified holes lined up as best as possible. These holes will then be bored out to take these bolts, and there'll be standard bolts put into the current oversized bolt holes, which should work just fine. Well, it'll certainly line up exactly right. Anyone familiar with Honda MB100s will know that the reed valve that normally goes in here is single-sided. There's two petals on one side. A well-known mod is to fit an RD350, one of the old air-cooled ones, fit a reed valve from that. With a little bit of cleaning up down each side and a bit more work, you can fit it in. Now this cylinder's got a little plate attached to it to space it out a little bit, and there's quite a bit of DevCon in here as well, just to clean it up and also to direct the air where it needs to go, which is down into these ports. So this reed block has been quite heavily modified, and as you can see, the two steel petals on each side have been replaced with a single carbon fiber petal each side, and inside there is a aerodynamically shaped splitter which helps direct the air evenly to each petal. Bit hard to see, but there's also DevCon in there as well, which also shapes the port where the air flows to the reeds. I don't know if it makes any real difference, but this reed valve has always been on engines which have done okay, 22.5 horsepower with not any really fancy porting. Using this reed valve, you can definitely hear it on the dyno. The intake has got a completely different sound to it when I'm using this reed valve. I can tell as soon as I fire it up that this is a reed valve I've got on it, versus one other that might look externally the same but hasn't had the work inside like this one does. Carburetor wise on this engine, I was hoping to use this 34mm semi downdraft carburetor. It's quite a nice carb. I've used it on my good engine, the MB100, that's made 30 horsepower on the dyno. Because with the port on the motor, it actually has quite a down angle on it, so this carb is ideal for that. The only trouble is that requires carburetor mounting rubbers, which will actually, this will fit into. Now this one is really designed for, or is designed for, I think only a 28mm carb, but I used to run a 32mm round slide Mikuni, which worked real good, but this 34 is way better, and is a very nice carb. But I might not be able to use it just simply because it won't fit into the carb mounting rubber on the reed block. We'll see.